Remember that time Richard decided to model and 3D print an entire arcade machine?
A museum in Gloucestershire has 3D printed a historic arcade machine.
The original is so expensive that 3D printers were used to make this copy.
And not just any arcade, we produced Computer Space, the first ever commercial arcade video game that was available, and it's been on display and playable in our museum ever since for people to enjoy here in the Arcade Archive. Well, he's been at it again to produce another historic machine in the name of letting people experience arcade gaming history firsthand. So strap in for 3D modeling, construction, painting, resin coating, glitter. It's got it all, everything that's needed to construct a brand new arcade machine from the 1970s, a replica of a historic machine. And if that wasn't enough, we've also got an interview today with the former Vice President of Game Publishing at Microsoft, Mr. Ed Fries. So this video really does have it all. So, what is the game? It's from 1973, it's by Atari, and it's called Space Race. Space Race was released in July 1973, and it was the first ever arcade game of the racing genre, and the first with an objective to cross the screen while avoiding obstacles. The game comprises of 2 players who must navigate a path through the asteroids to reach the top of the screen first. Each time you get to the top, you score a point and you start again from the bottom of the screen, and the time runs out while you're doing this, which is represented by the line in the middle there. That goes down as the time runs out, and the player with the most laps or points at the end wins the game. The game can be adjusted from 45 seconds to 3 minutes long, and controls for each player are simply up and down. The idea for Space Race was devised back in 1971 during the development cycle of Computer Space. But the decision was made to produce what they considered to be the more complicated game first. Now they soon learned that in the infancy of this new entertainment medium, that simple would be more accessible and the public would therefore take to it, and that would be more successful. That was a hard lesson learned by these guys. No better was this demonstrated than with their smash hit game Pong in 1972. Following the release of Computer Space, Atari founder Nolan Bushnell met with Bally and its subsidiary Midway Manufacturing and began discussions about designing games for the company. In June of that year, an agreement was signed, and that would help to keep some cash flowing into Atari. A successful game release would see Atari earn 3% royalties from Midway, and the idea was to come up with a car racing game. However, to meet that agreement in September of the same year, Atari met with Bally Midway to discuss their new game idea. You know, the game that would ignite an entire industry after the less than warm reception of Computer Space a year earlier and make Atari a bucket of cash. It was, of course, Pong. But Bally and Midway weren't convinced by Pong. They looked at it and they said, "No, thank you very much, we don't want that game. Come up with something better, please. We want our racing game." A blessing in disguise perhaps for Atari, because they went ahead and released Pong, and of course it became that smash hit success. Atari then revisited the Space Race idea, or Asteroid as it was called at this point in development, in the hope that it would be a quick and easy project to fulfill the Bally Midway contract. The success of Pong meant that they now had bigger fish to fry and likely wanted to conclude obligations quickly. But Atari also wanted to find new ideas, as in the wake of Pong's success came a slew of clones, copies and rip-offs of their game. Al Alcorn said, after the successful introduction of Pong in 1972, numerous companies copied it, and I estimate that copiers made and sold twice as many copies of Pong as Atari did. These copies were made by small manufacturers that did not have the ability to design these new high-speed digital video games. We competed with the copiers by creating new games and selling as many as we could before they were able to copy it. Space Race was one such game, and it was also the first Atari game to have joysticks. Atari could hardly complain though. Magnavox would later sue Atari for pinching the Pong idea from their own game, which was part of the first home console, the Magnavox Odyssey here, a demonstration of which inspired the Atari game originally. Anyway, Midway were happy that Asteroid satisfied the agreement and released their new game in 1973, which you can see is in a wooden cabinet, With the two-player joysticks on the front there, it looks like a pretty standard 1970s arcade cabinet. But then, Atari went and released the same game with the title Space Race, and subsequently, thanks to a 1974 deal with Namco, who would become responsible for Japanese operations, it would be released in Japan. However, what stood out about Atari's own offering was the cabinet itself. Like the earlier Computer Space, it was a fiberglass construction, this time featuring an asymmetrical design that looks like it could have split away from a passing asteroid and crashed into the Earth. It's really quite something. But few of these cabinets would ever have been seen. It's reported that only 50 were made from fiberglass before switching to this wooden design, this more traditional design, on account of the cost of manufacturing them. One of the ways we're able to keep the lights on in the cave is thanks to the support of PCBWay.com. If you're interested in today's episode, you will no doubt be interested in the services that they offer, including PCB manufacturing, of course, CNC milling, 3D printing, and their shared projects section, in which you'll find plenty of retro and vintage computing projects that you can order with just one click. I'd like to thank PCBWay.com for supporting the Retro Collective. Go and check them out at PCBWay.com. So when all of these things come together, the fact that it's by Atari, the limited run of just 50 machines, 50 originally, but how many remain in the modern day? It's got to be single figures, maybe less than 5. I don't know how many are out there, but it means that it is one of the rarest, most sought after and most collectible arcade cabinets you could ever possibly wish to have in your own collection. Now, if one did come up for auction, as much as I'd love one, I'm not prepared to put my house up for sale to be able to afford it. I'm sure it would command a huge price if one ever comes up. So we settled on creating a replica for the arcade here, the arcade archive. But where do we get the reference points from? How do we get the dimensions? How do we get the shape so that we can model and 3D print our own one? Enter Ed Fries, the former vice president of games publishing at Microsoft, who just so happens to have one in his collection, and a Computer Space, as you'll see behind him. So let's go and see him now, where he tells us the story of how he got hold of his own cabinet and how he helped us.
So the deal with this cabinet, there's evidence that it was originally created for Pong. So, after they did Computer Space for a company called Nutting Associates, Nolan and his partner Ted Dabney left and started Atari, and their first game was Pong. And so there's actually one or two pictures of a Pong running in this cabinet, like from back in the day. I don't think anyone's ever found one. And so my guess, and now I'm just speculating, that Pong so unexpectedly became so popular very quickly that there was no way they could keep up with in production with a fiberglass cabinet. So these were just prototype cabinets that they made. And so they just went, all the Pongs that I know of, I mean, there are some funny Pongs, like one that's in a barrel and a few other things, but no one's ever found a Pong in this, other than those pictures that are out there, in this particular cabinet. But then, Space Race was the next real game after that. And so I guess they decided we might as well use these, and made a few games with Space Race. Van Burnham, who runs something called Supercade, she has a series of great books on early arcade machines. I got a text from Van one day and saying, "Did you see this? Showed up on eBay." Anyway, I ended up talking to the seller, and he was an estate manager, a guy who sells, when someone dies, who comes in to sell off their possessions, right? And so he came and he walked into this guy's house, and the whole first floor of this house was an arcade. The whole second floor, by the way, was a casino, like a working casino with slot machines and all this stuff. Anyway, it turned out the guy worked his whole life for one of the Las Vegas casinos. And every once in a while, he would see something he liked and he would take it back to his house in Los Angeles to fix it. I think he was like the head repair guy. So the machines he was selling were just like out of a time capsule. I mean, they were perfect condition and had just been preserved since the early 70s. So really exciting to have a chance to buy it.
And so how is it then, Ed, that you came to motivate Richard with this space race project?
I really enjoyed the recreation of computer space. And I just tauntingly posted a picture of Space Race and said, you should do this one next. And I didn't really think he would do it, but apparently he saw that as a challenge he couldn't pass up. So then he reached out to me and he asked if I could take some pictures, which I did. And then he asked if I could do a 3D scan. And I wasn't sure how to do that, but I said I'd give it a shot. And I just grabbed the first thing I could find in the App Store for my iPhone. It was called 3D Scanner. And I walked around it with a phone, and the scan was terrible. And I was like, well, that didn't work. And like, I'll try it one more time, and I'll like mess around with the settings a little. And I made it so it had a much narrower field of view or something. And I walked around it again, and it came out just perfect the second time. I was amazed how well it worked.
It was just perfect, says Ed. So he sent the model to you, and I must admit, when you told me you'd asked Ed to laser scan the arcade, I thought he had some kind of specialist equipment, but he's just used an iPhone, which is impressive.
Yeah. Was
it perfect, the model you received?
It was pretty good.
Okay.
For the fact that it was an iPhone, using the LiDAR scanner on the iPhone, which is not bad, I was quite surprised how well it came out. But the main thing that you notice when you get the model back is it looks great on screen, a bit like a 2000s video game where you've got the texture map and the full color over it. So it looked amazing. You could see inside the machine where the monitor was, you could see all of the outside. But as soon as I switched that color layer off and I just had the raw texture, you could see all the imperfections and all the bits where it hadn't really got it quite right. But the main point was that it got all of the geometry, captured all that geometry from the measurements from the floor to the controls, all around the bezel, everything. So that was the reason why I asked Ed if he could. I didn't know how he was going to do it at this point, but I wouldn't normally ask someone to do that. But I knew if I didn't, I would have to be going back to him constantly saying, can you measure this? Can you measure this point from the floor to here? Can you see how wide this was? Because that's what I had to do with the computer space with just pictures. Or when I had photographs, I had to make lots of measurements from Pong that it was stood next to and all that sort of thing. So I didn't want to have to keep going back to Ed because I would have spent a lot of his time just having to constantly give me measurements and check that the geometry and the angles are right. Whereas with this model, I could use it and get on with that scan.
So you've got what you need then to just shape it out, smooth it out, and hopefully get something that we can use.
Absolutely.
So let's see how Richard tackles this process.
So we've actually got a lot of the outside surface detail, and even on the inside you can see features for the monitor, you can see the coin mech, you can see all of the controls, and pretty much everywhere, even where the monitor was actually placed inside the housing. So this is a really good starting point. We can see detail on the back as well, which will help us with construction of the machine, and actually even down to the point where you can see the mains cable coming out the back, which is really impressive. This 3D model is an object file, so it has actually a texture map surface on it. So if we look at that texture map, you can get a bit more of an idea of the sort of way the iPhone scans and actually gets all the geometry and overlays it with a texture map. A bit like you would do in a computer game, really. This is just the same sort of thing. What we can't do really is use that texture map, so we do have to remove it, and that's when you actually see the quality of the 3D model itself, which is okay, and it gives us all the features we need, but it does show up the limitations of using a scanner, especially at this size when you've got a full-size arcade machine that you're trying to scan with a handheld device like an iPhone. But that still gives us a lot of key points we can use to remodel the arcade machine, and actually that's a great starting point because it means all of those dimensions, as soon as we get the scale right, they're going to be all correct. So if we get the scale, we chop off the bottom, tidy that up, which is what I've done in this piece of the model, we can start actually overlaying our drawing on top. So first thing to do is just double check that we've got the scale right. I did ask Ed to measure from the bottom to the front of the machine and from the bottom to the back of the machine. So here we've got everything we need to know that this is actually now at the right scale to be able to retrace this model in 3D. And that's exactly what happens next. We can basically load this model into our CAD package, and we can use that as a reference point to start creating all of those key points. And that's really all you're doing is a wireframe model, very low resolution. Doesn't have to be solid mapped at this point. It can just be really basic wireframe, just to make sure that we've got all those key points and that they're in the right place and we've not missed anything. So we end up with a wireframe model, and then after that wireframe model, you can just double check you got all the angles right, everything else like that. We can start to produce a fully featured solid model. And that takes a little bit more work, so that's going to be quite a bit more in-depth modeling. We need to have features inside for shelves, for the thickness, and I did this all manually. So what we've got here is a manual thickness creation because I wanted different thicknesses around the model at different points. It's quite tricky to do, and you do need to spend some time thinking about how it's going to 3D print as well, because this is going to have to be cut up into sections. But after a little while, you sort of get into it and create a 3D model that you can then use for cutting up and put into sections. We can now really see the difference between the original scanned model and the recreated model that used all of the key points, but basically turned that into a wireframe and then a solid model that we can output. So the next stage in this model process is to double check everything looks okay and you haven't got any open edges or any holes basically that cause you problems. If there are any holes, you're going to have a lot of problems exporting this and turning it into a part that can be 3D printed. But before all of that, we do have to finish off some of the blending and smoothing, because at the moment the edges are quite sharp and we really need to just knock some of those features off and turn the fairly low resolution 3D model into something that's a little bit more smooth and has a bit more texture. The original fiberglass machine, of course, had quite smooth edges, had quite soft rounded corners. So we can use our blending tool here to basically go over the whole surface, and this actually adds quite a lot of quality into the fairly low resolution. It keeps basically subdividing all of the sections, and you end up with a very smooth, very high quality model that then you can then cut up into sections. So I tend to use a number of programs to do this, but you can see straight away that if you put this on the 3D print bed, it wouldn't fit. It's a really, really large machine, so it needs to be cut up into quite a number of sections. Once you have everything cut up into small sections that will fit on your 3D print bed, it's time to just do the slicing process and double check that everything's going to print okay, so there's no overhangs or any missing sections. This can take quite some time, but at the end of it, we'll end up with a whole load of files, about 120 parts that we'll be able to put on the 3D print farm and print with basically scrap PLA that we've had lying around. So this is all just end of rolls or miscellaneous colors that I've had for quite some time that we're using to print all of the sections. It doesn't really matter what color it is because it's all going to be covered in filler and then resin and everything else. So we end up with about 120 sections all labeled up so we know what we're doing, and then we can start actually fitting them all together. So the first thing I always do is a test fit of each layer to make sure that everything slides in, and you will need to refine your settings here. So I've got a clearance of 0.2 millimeters to be able to make sure that each section slides in with a little bit of force, but not too much, because you don't want to have to be whacking these parts in because they will break and snap. I'm using Gorilla Glue Clear to connect all of the sections together. and I end up doing that for each one of the layers. So it takes a little while, but it's actually quite a nice process, and everything slots in perfectly, really. You end up with a whole load of sections from the base section at the bottom all the way through to the top. And a few of them needed a little bit of coaxing to get in to fit, but there wasn't really much sanding or too much manipulation that needed to be done on these sections. A few things needed to be clamped in place just to make sure that they all stayed just where you needed them. Otherwise, they're going to cause you some issues if you haven't got everything leveled up. And then I can start gluing the sections together. After that, then the bigger sections can all be glued together on top of that until you end up with basically the outline of your 3D printed arcade machine. The base has a solid section of MDF that's screwed to the first layer of the 3D printed parts, and then all of the other layers get stuck on top. I did this in 3 big sections and then glued 2 of the sections together and then glued that on top of the 3rd section. So we ended up with the full-size 3D printed machine that I could lift into place and glue and just get everything nicely lined up. After that, we can then put in some more grab adhesive to fill up all of the sections. And whack in the very last section at the top, which was very satisfying to see that one just drop in. I'm going to reinforce this with tape inside and do quite a bit more work to the outside, but I certainly won't be sanding any PLA. You definitely don't want to be doing that. The idea with being able to print something this big is to be able to cover it in something that you can sand very easily. So the first thing to do is to get all of those sections nice and solid inside, and then you can use more grab adhesive and fiberglass tape to reinforce all the internal sections. On the outside, then you can think about putting on the filler. What I've actually got to do now is mix up a solution for the outside, and this will be the first thin layer of filler, and that's 50% filler, 50% instant grab adhesive mixed up and then smoothed all over. That gives you a lock and sort of keys into the PLA and allows a light sanding, and then you can put a couple more layers over the top of that, thin down a little bit more, so that's got more filler in and less grab adhesive, and that allows it to be nicely smoothed all the way down. So once you've done that, then you can seal it, then we can paint, then we can put the resin on. So first thing I've got to do is mix up a solution and get all of the outside covered in the filler and grab adhesive. So putting the mixed filler on a machine this size or any sort of model that you've 3D printed is really up to you how you do it. I tend to just smooth it all on with a number of different methods, just from picking it up and putting it on by hand, or actually using spreaders to try and get everything over onto the machine. A small sponge is also really useful just to smooth everything down. You don't want to be sanding too much, so you want to use a wet sponge to be able to try and get everything as reasonably smooth as possible. You will have to do some sanding, but you want to get it to the point where everything sort of is covered with a thin layer of that mixture of the grab adhesive and filler. Once you've got everything nice and dry after a few days, you can then take a sanding sponge or some fine sandpaper and actually just give everything a light sand. What you're trying to do here is just basically get everything nice and smooth so you've got a surface to be able to seal before painting, which is the next step in this process.
And it's at this point where we're going to draw the episode to a close today. I know you're desperate to see this finished, but we're going to break for the weekend now. And I promise you, this is going to be our very next video next week. We're going to get straight back onto this. Richard has been experimenting in the meantime with colors, with resin.
Yeah.
That's a process that you refined in the Computer Space project.
Indeed.
And is this a more challenging shape, would you say, than Computer Space for the resin process? Or?
It definitely will be, yes.
Okay.
The Computer Space, although it had some nice curves, I had to do that in a number of angles. This one, it's got some really interesting pockets that the resin is going to sit into. So yeah, I'm not quite sure how I'm going to do that yet.
Okay, so work to do on that. We'll talk about what monitor we're going to put in there, what hardware we're going to put in there. This was a TTL logic game back in the day. This doesn't need a lot of power to emulate it, but we want to get it right and we want to give people a really authentic experience. How do we create the joysticks? Because this is the first arcade machine from Atari with joysticks, and unlike any other joystick that I've seen, this wasn't an off-the-shelf part at the time, was it?
No, impossible to get hold of, and there's no really parts out there that you can even scan or do anything.
Yeah.
So yeah.
So lots of challenges ahead of us, but we will tackle them in our very next video. I hope you'll come back and join us. In the meantime, if you'd like to book a ticket to come and see this when it's finished, head to retrocollective.co.uk, book yourself a visit, and subscribe to the channel if you haven't already done so. Thank you for your work today, Richard.
Thank you.
And we'll see you all next week. Bye-bye.
Bye-bye.